Hello, my dear students. Last class I explained about pile groups. Today, let us discuss about efficiency of pile group. When several closely spaced piles are grouped together, it is reasonable to expect that the soil pressure developed in the soil as resistance will develop. The bearing capacity of a pile group may or may not be equal to the sum of the bearing capacity of individual piles constituting a group. Theory and test have shown that the total bearing value QUG of a group of friction piles, particularly in clay, may be less than the product of the friction bearing value QUP of an individual pile multiplied by the number of the piles n in a group. Okay, here it is observed that the bearing capacity of the pile group may or may not be equal to the sum of the bearing capacity of individual piles in a group. And also the theory and test have shown that total bearing value, that is QUG, of a group of friction piles, especially in the clay, it may be less than the product of the friction bearing value of an individual pile multiplied by the number of piles n in a group. However, there is no reduction due to grouping occurs in end-bearing piles. For combined end-bearing and friction piles, only the load carrying capacity of the friction portion is reduced. A method of estimating the bearing capacity of a group of friction pile is to multiply the quantity, that is NQUP, by a reduction factor called the efficiency of pile group. Okay, see here you have to see that there is no reduction due to grouping occurs in end bearing piles. Only for the friction piles it happens. For combined end bearing and friction piles, only the load carrying capacity of the friction portion is reduced. Okay, there is no reduction in the end bearing piles. So a method of estimating the bearing capacity of a group of friction pile is to multiply the quantity, that is NQUP, by a reduction factor called the efficiency of pile group. That is, this is the formula to find the efficiency of pile group, that is QUG, that is equal to the total bearing value, that is equal to N into QUP into new G. That's why here it is told a method of estimating bearing capacity of a group of friction piles. This is a group of bearing capacity, QG is there, is to multiply the quantity of NQUP by the efficiency factor, that's reduction factor, that is called efficiency of pile group. So QUG is equal to N into QUP into nu into G, where QUG is load carried by group of friction piles and QUP is load carried by each friction pile. N is number of piles, nu G is efficiency of pile group. The efficiency of pile group depends upon the following factors, that is characteristics of pile, that is length, diameter and material, and spacing of the pile, total number of piles in a row and number of rows, etc. A number of formulae are available for determining the efficiency of pile group. Some of them are given here. Okay, so mainly the efficiency of a pile group depends upon the characteristics of the pile, that is the length, diameter and material, then spacing of the pile, then total number of piles in a row and the number of the rows. So there are many formulae to find this efficiency of pile group. Some of the important one are as follows. The first one is Converse-Labarre formula, that is here efficiency can be calculated using this formula. Nu G is equal to 1 minus theta divided by 90 into n minus 1 into m plus m minus 1 into n divided by mn. Okay, where m is number number of rows, n is number of piles in a row, theta is tan inverse of d divided by s degrees, d is diameter of pile, s is spacing of the piles. Okay, this is the one formula to find the efficiency of pile group. Other formula is Seiler-Kenny formulae. Here it says that mu g equal to square bracket 1 minus 0.479 into s divided by s square minus 0.093 into m plus n minus 2 divided by m plus n minus 1. Okay, bracket close, plus 0.3 divided by m plus n, where m is say number of rows and n is number of piles in a row and s is average spacing center to center in meters. Feld's rule, according to this rule, the value of each pile is reduced by 1/16 on account of the effect of the nearest pile in each diagonal or straight row of which the pile in a question is a member. This is Feld's rule. What he says is the value of each pile is reduced by 1/16 on account of the effect of the nearest pile in each diagonal or straight row of which the pile question is a member. So next let us see how we can design the pile group or piles. The bearing capacity of a single pile in clay is mainly due to friction and the point bearing resistance may be negligible. Okay, so mainly in the case of single pile in the clay, the load bearing capacity is mainly affected by the friction. The point bearing resistance is very less. In a pile group, the piles are connected at its top by pile cap which is rigid. Hence, the failure of the pile group is likely to occur at a load which may be smaller than the ultimate load carried by each pile multiplied by the number of piles in the group. The area of the pile group along failure surface is approximately equal to the perimeter P of the pile group multiplied by the length L of the pile. The ultimate load will then be equal to QUG is equal to P into L into RF plus A into RP, where A is cross-sectional area of pile group, that is at the base B into P equal to B square. P is perimeter of the pile group, that is 4B, and RF is shear strength of soil, that is equal to tau equal to QU divided by 2 for clay soil, and QUG is equal to, if you substitute all these value in this equation, what we get? P is 4B into L into RF plus A is B square into RP, that is equal to 4BL C dash plus B square into 9CP. This I have explained in the previous static formulae. So if you substitute that equation, you get QUG is equal to this. This is the two piles. Here you can see this is two piles. One pile, two piles. This is a three pile and this is a four pile. 1, 2, 3, 4 and this is a 5 piles. In absence of any other specific data, both C dash and CP may be taken equal to QU by 2 here. In this equation, if C bar, if we don't know that, it can be considered as QU divided by 2. If however, piles of the group are so spaced that they act individually rather than acting in a group, the total load capacity of n pile is given by this formula. QUN is equal to n into QUP. QUP is load of individual pile. So, the total load is equal to number of the piles into load of individual pile. Okay. The ultimate load QU of the pile groups will be then equal to lesser of QUG and QU determined above, and the permissible load will be equal to QU divided by factor of safety. Then efficiency of the pile group can be calculated using this formula, that is mu G equal to ultimate bearing capacity of the pile group divided by N into ultimate bearing capacity of single pile in the group. So here what you have to calculate, first ultimate bearing capacity of the pile group, then that divided by N is the number of piles in a group into ultimate bearing capacity of the single pile. So this also gives the efficiency of the pile group. This is of single pile, this is a double pile, and here this is a three piles, triple piles, which are supported by a pile cap. Here you can see this is a pile cap. Its value for bearing or friction piles at sites where the soil strength increases with depth is found to be 1. Okay, for friction piles in soft clays, the value of N is less than 1. The actual value of N depends on soil type, method of pile installation, and pile spacing. When piles are driven in loose sandy soils, the soil is densified during driving and N is greater than 1 in such cases. It has been observed that if the spacing between pile is more than 2.5 times the pile diameter, the group efficiency is not reduced. The large pile to pile spacing will increase the overall cost of the construction. The reduction in load capacity due to group effect can be estimated empirically. So this is the IS code recommendation to find the spacing of the piles in a group. That is, if the length of the pile is 12 meter, then spacing is 3D, 3 times of the diameter of the pile. 12 to 24 meter length of the pile, the spacing is 4D. If the length of the pile is greater than 24 meter, the spacing is 5D, where D is the diameter of the pile. Okay, so this is about efficiency of pile group. Now let us discuss about settlement of pile groups. Due to group action, both immediate and consolidation settlement values of a pile group are greater than those for a single pile. Okay, so because of the group action, both immediate and consolidation settlement values are greater than those for a individual or single pile. For bearing piles, the total foundation load is assumed to act at the base of the piles on an imaginary foundation of the same size as the plan of the pile group. For friction piles, it is virtually impossible to determine the level at which the structural load is effectively transferred to the soil. The level used in design is at a depth of 2/3 the penetration depth. Settlement of pile group in clay. The settlement of a group of friction piles can be computed on the assumption that the clay contained between the top of the piles and their lower third point is incompressible, and that the load is applied to the soil at this lower third point of the pile. You can see here, okay, lower third of the point of the pile. Here the load is transferred like this. This is a load spreading line, this is a compressible fill, and this is a rock. The presence of pile below this level is ignored. The load is assumed to be uniformly distributed at this level and is assumed to spread at an angle of 30 degrees with the vertical. The soil below this level is divided into a number of layers, and sigma P and delta sigma are calculated at the middle of each layer. The settlement of each layer is calculated by using this equation. P is equal to H into Cc divided by 1 plus E naught into log 10 of sigma naught plus delta sigma divided by sigma naught, where H is thickness of the layer, E naught is initial void ratio, sigma naught is initial stress at the center of the layer, and Z is depth of the center of the layer below the ground. The total settlement is given by P1 plus P2 plus P3 till Pn, where delta sigma is additional stress due to piles and it is equal to total pile load Q divided by area of the spread at the center of